Ladies and gentlemen, to lesson 9A-7. So this is that supplemental chapter. More on proportional relationships. Today we will be graphing them, not just analyzing graphs given to us, but actually creating graphs. Go ahead and pause, look at your answers. Come on back when you're ready. I got a few pages for you. Second page. And one more. Make sure to bring any questions you have to class. Let's talk about where we've been, determining if things are proportional. If the ratios are always the same, they have a constant of proportionality. Also writing equations given a table. Next up, given a graph, or as in today, you're actually going to make your own graph, still determining if it's proportional, finding that constant of proportionality, and finally writing an equation for it. Remember that eventually we will be able to write equations for relationships that are not proportional, but for now we're sticking with proportional relationships. All right, let's talk about this example. We do have notes available, so go ahead and fill these notes out as you wish. Katrina wants to purchase a new color photo printer. The table shows the number of color photos one printer can print. Let's go ahead and use that relationship to determine if it's proportional. Now, we already know that when we are examining the ratios, we want to make sure to write as in the number of photos depends on the time. So in this case, we have 14 to 1, we have 28 to 2, we have 42 to 3, and we have 56 to 4. Now, if you were to divide or reduce each and every one of those, you would find, yes, there is a constant of proportionality. Therefore, is it proportional? Yep. Now, you may write 14 to 1, or you may write 14. Ideally, you understand that we're talking 14 photos per minute. And of course, we are going to be able to write an equation. Now, can we use that equation to make predictions? Sure, we could continue the table on down. Meanwhile, we may also use the equation. Here the question is, how many photos? 6 minutes. So if I were to rewrite the equation, wake up, Mr. Callan. Y is equal to 14 times x. Where is that 6 going to go? One thing I forgot to mention, I will try to mention it from here on out. Always label your table. Here we know that the number of photos depends on the number of minutes, so we're going to substitute 6 in for x, and then we go ahead and solve that. In this case, there would be 84 photos. And of course, I could take that, write it in a complete sentence. But the big focus for today is on graphing it. The information in the table can be listed as ordered pairs. An ordered pair is a pair of numbers. This is an example, the ordered pair 1, 14. You don't say the comma, I guess you can. Used to locate or graph points in or on the coordinate plane. Now, remember please something we talked about yesterday. If the graph of two quantities is a straight line through the origin, then those quantities are proportional. Just a little catch up from yesterday. Sorry, we already did this. Yes, they are proportional. The constant of proportionality, you could have either written 14 to 1 or just write 14. Equation y is equal to 14x. Now, how do we graph this fella out? Well, remember, please, that the number of photos, the printed photos, that is what we are measuring. That is the dependent variable, and thus it goes on the y-axis. What does it depend upon? Well, it depends upon the time, in this case measured in minutes. Therefore, you're going to write time on the x-axis. Now, time very clearly goes by ones, although you could always go by halves, but I'm going to stick to ones here. What kind of vertical axis could we pick? Well, you can choose any scale that you want, as long as it fits all of the data. I could go by, if I went by fives here, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Fives is not good enough, so it's got to be bigger than fives. Now, if I went by tens, 10, 20, 30, 40, 50, 60, it doesn't use a whole lot of the graph, but it's still not bad. That being said, I notice quickly that if it goes up by 14s, well, hey, why not just use a scale of 14? Now in this case, we can go ahead and plot those points. So I'm going to pick a good size here. Let's make it a little bigger. There we go. And let's use red for the heck of it. We got one photo, so follow one photo up, 1 minute up to 14 photos. 2 minutes will be 28. 3 minutes will go up to 42, and 4 minutes goes up to 56. Now, in this case, if I were to be able to graph a line that goes right through the points and make sure that it at least touches, if not going through the y-axis, aha, this just verifies the fact that it's proportional. It is a straight line, which again is a bit redundant, that furthermore travels through or begins at the origin. So we'll keep talking about scale. Again, if you chose to go by a scale of tens or whatnot, that's fine. It just makes it a little more challenging to graph the points. Let's go on to our next example, please. Cost of 3D movie tickets shown on the table. Let's go ahead and determine if this is a proportional relationship, comparing the cost to the number of tickets. But I want to determine that going straight to graphing and just skip the checking the ratios for now. Let's build up the other skill of graphing this out. Now in this case, don't forget, we're going to build our habits together, Mr. Callan along with you. Labeling your axes, you're going to find out very quickly that the cost, measured here in dollars, not euros, not pesos, not pounds, whatever, the cost is dependent upon the number of tickets purchased or sold. So in this case, the number of tickets again appears to go up by ones, so why not just keep a pretty simple scale on the horizontal axis? As for the vertical axis, we need to go up by the same amount and at least get to 48. Yes, you could go by tens pretty quickly, 10, 20, shoot, you could go by, you could even go by fives here, but I want to graph my points very quickly and efficiently, and I notice if I look at those numbers, it appears that they go up by 12. So why not just go by 12s? Therefore, when we plot our points, we notice that one ticket cost $12, two tickets will be 24, 336, 448, and we assume that the relationship will continue. Therefore, we're going to draw a line through all the points, and if possible, traveling across the y-axis. Is this proportional? Yes, it's a straight line, and yes, it travels through the origin. Therefore, yes, it is proportional. Now, in this case, it appears to go up, little disappearing ink here. It appears to go up $12 for every one ticket sold, another $12 for one ticket, another $12 for one ticket. And of course, you can see that with the ratios, 12 to 1, 24 to 2 is also 12 to 1, 36 to 3 is also 12 to 1, as is 48 to 4. You may write 12 to 1, or you just may write $12 per ticket. And what is our equation? Y equals 12x. Now, let's talk about interpreting graphs or tables and telling us what they mean. Now remember, what is the point 112? What does the ordered pair 112 mean? So basically you want to say 1 blank mean and is related to 12 blank. I'm going to go ahead and say what I'm measuring first. The cost is, now which is the cost? Is it the 1 or the 12? Well, the cost is the $12. It's the y coordinate. Now, okay, so what does the X mean? The X is one ticket, so the cost is $12 for one ticket. Now, surely you can write a better sentence than that, but that just puts into words what these numbers mean. Onward we go. Anna was given a $75 gift card to buy CDs. Each CD costs $15. Determine whether the remaining balance on the gift card is proportional to the number of CDs bought by graphing on the coordinate plane. Now, I want you to think about a key word here is remaining. So remember, she started with $75. If she bought a CD, that means she is not gaining money on that remaining balance. She is losing money. She has less money to spend. Which means if we buy one more CD, another $15 CD puts us down to $45. Go ahead and fill out the rest of the table. Come back when you're ready. Naturally, the next digit would be 30. The next one would be 15. Is this proportional? Let's go ahead and graph it and find out. Now, in this case, the balance depends upon how many CDs she's purchasing. So the balance, which I should have written on the table, is measured in dollars, depends upon the number of CDs purchased. Sooner or later, we'll get kind of funky with the CDs purchased, but let's go with the horizontal axis, the horizontal scale, but let's stick to ones. And I seem to see some kind of pattern of 15s. So that is the scale I'm going to choose. Now you'll notice quickly that it does not use much of the graph. So well, could I have shown that? 15, let's try it out. 30, 45, 60, and so on. You notice I still have a balance scale, only this time it appears to be like $7.50, another $7.50, another $7.50, another $7.50. But I just wanted to show you that you can use more of the graph sometimes by mixing the scale so that it's not crunched in. Otherwise, if you can picture this, everything we did would have been in the bottom half of the graph, and you wouldn't even use this part up here. So it is best at times to go ahead and extend the scale as long as it starts at 0, as long as it goes up by the same quantity. Now in this case, I'm looking at 1 CD purchased means $60 is remaining on the balance. 2 CDs would be 45, 3 CDs would be 30, 4 CDs 15. Now let's go ahead and draw a line through those points, making sure that that line at least gets to the y-axis. And actually, I'm not sure I would say a line here. Notice if you got no money remaining, then you're not going to continue. Maybe we should have called this a line segment. In this case, we go and ask ourselves, is it proportional? Mr. Callan, it's a straight line, but it surely does not go through the origin. If you don't believe me, check out the ratios. 60 to 1 is 60. 45 to 2 is 22.5. And 30 to 3 is 10, and 15 to 4 is like 375. The point is the ratios, there is not a constant of proportionality. So while this does make a straight line, it is not a proportional relationship. All right, one more example before you hit up your homework. Cost of renting video games here, shown on the table below. Determine whether this cost is proportional or not. Let's go ahead and graph it out. Noticing that the cost is dependent on the number of games, we're going to make sure to put the cost on our vertical axis, and the cost depends on the number of games rented. All right, let's stick to it. Meanwhile, the cost, I don't know, looks like going up by ones is good enough, so let's just go up by ones. Does it cover all of the numbers that are given? Yes, it does. And so we go ahead and we plot our points. 1 game rented is $3, 2 games rented is $5, 3 games rented is $7, and 4 is related to $9. We're going to go ahead and extend a line through the points, making sure that it at least touches the y-axis. And Houston, we seem to have a problem. Not a problem. Maybe they charge a $1 deposit. I don't know. But is it proportional? No, because while it is a straight line, it is certainly not through the origin. As a unproportional relationship, there is not a constant proportionality, and we cannot yet write an equation for it, although some of you might know how to. Let's wrap up with interpreting what the 0.13 means. Remember, here we're talking about cost, so that's how I'm going to begin my sentence. The cost will be, okay, now which of those numbers in the ordered pair is the cost? Well, the cost is the y value, so the cost will be $3 for, now what does that 1 mean? That 1 is the number of video games rented. For one, how about I say for renting one video game. Now, the biggest mistake is sometimes people will mix up the numbers and say the cost is $1 for renting 3 games. That's why it's really a wise idea to immediately upon seeing a table to write Y and X in the appropriate places. And the same for the graph. If the graph doesn't write that, you should probably do that on your own. Now, ladies and gents, remember, please, the 2 characteristics. If you're looking at a graph, what 2 things tell you that it is proportional? I'm not going to say it. I want you to think about it. If you need to, rewind and continue watching the video again until you find those 2 characteristics. Meanwhile, assignment number 8, there will be a few graphs to do along with some other problems on your sheet of paper. I'll try to put those together so that you have those all in one file. That's what we got, folks. That's all I got for today. Take care and let's grow.